Hi, welcome to the Signal Pad. Today I have a pretty special episode for you guys. I'll be covering the industry trade show at the International Microwave Symposium. Now, the IMS conference is a week-long conference. It's typically co-located with the RFIC conference, which is a Radio Frequency Integrated Circuit Symposium, and they go around the country, and this year it was in Philadelphia. Next year it'll be in Boston. And it's really an amazing event to be there. It's one of the largest events in electrical engineering and microwave engineering in my field. Thousands of people attended from all over the world, hundreds of papers from different research institution, industry institution, and even government places are going to be presented at these conferences. It really can't replace being there. At the same time, aside from a lot of different activities, there is an exhibition, which is an industry trade show exhibition that's held here, which hundreds of vendors from all around the world come, and they each have booths, and they show off the latest and greatest equipment and instruments and components and even material engineering that they have created. You can spend days just walking around just for the exhibition itself, let alone all the wonderful research publications that are provided. Now, I thought that it would be cool to do an overview of the exhibition, and I really underestimated how long it takes to actually go from booth to booth and record even just a fraction of the people who are there. So I ended up getting about an hour of footage, about 20 different vendors. That's 20 out of almost 500. So it's really difficult to get it. So for next year, I think I'm going to do it a little bit differently, get even more footage and involve you even more of some of the great things that are happening. Now, some of these vendors, because this is such a big deal and such a big important event, they release some of the equipment at the same time that the exhibition is held. So it's pretty serious. It's going to be very interesting walking around, so I'm going to go through this. Now, what I want from you is to give me feedback on how you want this to change so that in the future we can get even a better return on being at the conference. Now, I visit the conference every year. This is the first time I've decided to do this recording because the people who organized the IMS press that it would be a good thing for the website. So we're going to continue doing this, but I need your feedback, so I might even do interviews with some of the people who are doing the plenary or go and cover some of the different events at the conference. But I'm not going to keep you waiting any longer. Let's walk around the exhibition center and see what it looks like. So here at the Keysight booth, of course, one of the strengths of Keysight in general is that they have a massive ecosystem of components, parts, and software. Now, what they're showing here at IMS is clearly focused on showing what they can do by combining all of their instrumentation and softwares into one package. Now, this is obviously very important because you want to stay within the ecosystem of a single vendor for seamless connectivity between their equipment. So this is a test bed for generating and testing next generation of communication systems, 5G and beyond. It doesn't really matter, and even though this setup is right now set for 802.11.AY, so they obviously have ultra high performance arbitrary waveform generators. Here's a module example of that. They have this particular one is 65 gigasample per second. They obviously have a huge set of signal generators. On the right side here, I'm going to pan the camera. They have their example of doing two different types of signal analysis on two different instruments, which is nice to see here. They have the UX8. This is a 3 Hz up to 110 gigahertz single sweep spectrum analyzer. This is the widest bandwidth single sweep spectrum analyzer on the market with two inputs, 110 gigahertz input and a 50 gigahertz input, which is nice. Separating the two connectors is hugely beneficial because if you're measuring below 50 gigahertz, you don't want to be using a 1mm connector. So here they're doing an AY example, so this is at 60 gigahertz. Now, the UXA has an internal analysis bandwidth of up to 8 gigahertz, so you can do, of course, measurements centered around any frequency up to 110 gigahertz and do full analysis directly on this instrument. Now, on the right side is the DSA, which is a 160 gigasample per second, 63 gigahertz bandwidth scope. Now, this has so much analog bandwidth that you could do AY demodulation directly on that. But if you look at this setup, you kind of get an idea of what the vision is. The vision is that you will connect all these instruments together. You will run the software here. They're up converting directly to the 60 gigahertz band, and there is two horn antennas which are facing each other. So you're doing all of the analysis simultaneously on several instruments at the same time. All the software is connected. All the softwares are aware of every single instrument that's in the setup. This is what Keysight does. This is the strength of having huge integration of software and hardware in multiple domains. So we're going to go in a couple of other stations as well. Just wanted to give you an appreciation of really the flexibility that Keysight brings to the test and measurement market. And of course, Keysight was not going to miss the craze of the USB-based instruments. These are brand new form factors of instruments from Keysight. These units are network analyzers, and they go all the way up to 26.5 gigahertz. I believe a 2-port, full 2-port network analyzer at 26.5 is roughly around $33,000. But you can also connect them together, synchronize the LO, and get a 4-port VNA, of course, all USB-based as well. The software will recognize this and synchronize everything together and give you a 2-port instrument. New ECAL modules that go with these units, as you can see over here. Obviously, all the brand new softwares that Keysight has written with this works with all of these units at the same time. And I will show you this here on the computer. You can see all the way in the corner a classic VNA structure. Now, what is really nice is that this new form factor actually extends to 2 other set of products which are unfortunately not here right now. There's an oscilloscope up to 1 gigahertz of bandwidth, 2-channel, as well as an AWG with up to a gigahertz of IQ baseband generation, 16-bit architecture, which is more than 65 dBc. They can give you a spurious, very dynamic range. So new USB-based instruments from Keysight, now finally also on the market, competing with everyone else's units. Very powerful, I believe. Perhaps some of the FieldFox technology that goes into their portable network analyzers are more surely going to be present in these units as well. So check out, they just released on June 11th press release, so take a look. Lots of interesting features coming up. And here, of course, we have the Keysight FieldFox microwave analyzer. If you know anything about these units, you'd know that they are the only company with a 50 gigahertz full network analyzer and spectrum analyzer in such a form factor. These are really extraordinary devices. Now, despite the size, these actually support real-time bandwidth. So this guy has a 10 megahertz real-time bandwidth. We can see the spectral view here in real time. And because it supports that, now the unit can be connected directly to the VSA software, and the VSA can take advantage of the digital modulation that happens inside the unit. So you can do everything you traditionally do on the VSA, taking advantage of the 10 mega analysis bandwidth of the FieldFox directly with it. So you can do real-time demodulation on the go with all you need is a laptop and the FieldFox by itself. So even though these units have been around for some time, the firmware upgrade and the software upgrade continues to add features to these units. So I'm going to show you something else they've added it, which is quite unique, and I don't think anyone else up to 50 gigahertz supports these type of features. So let's take a look at the next thing. So now the FieldFox has also been upgraded to do noise figure measurements, and not only just do noise figure measurements, but because it supports full customization and configuration with external amplifiers, here they have their ultra broadband external amplifier specifically designed to aid noise figure measurements to create excess noise in situations where the noise figure is as small, or in a situation where you just simply don't have enough gain from your device itself. So this is a very handy, it's a 50 gigahertz preamplifier powered directly from the unit itself. It's really not connected to anything else. The noise source is all the way at the top here, also powered from the unit. So this is really completely standalone. And we're looking at a noise figure starting from 5 gigahertz all the way up to 50 gigahertz on this unit. And because the setup is all aware of the kind of components you have, you can enable these error bars directly in the noise figure measurement setup. And this gives you an uncertainty of your noise figure depending on whatever parameter is changing in the noise figure measurement itself, ENR uncertainty or any mismatch uncertainty. You can get these bars in real time as you're doing your measurements, which is of course huge, because you need to know if you can rely on this measurement you're getting, especially on the field where time is really important. And once you know your uncertainty and you leave the situation you're in, if you're somewhere on the top of an antenna, you want to make sure your noise figures actually make any sense before you let go. And this is fully standalone, everything connected to the unit by itself. Software upgrade on existing models, really quite flexible units. I think these FieldFoxes are pretty much one of the most advanced portable instruments that are on the market today. And of course, 5G testing is critical. So here we have an Anokiwave 256 element phased array. Anokiwave is all over the conference here creating large scale arrays. And one of the critical aspects of doing testing on the system is to get radiation patterns. And radiation patterns come in several different formats here. So this unit is actually able to do 2 different things at the same time. It can rotate the DUT, that's the device under test over there, and it can measure the radiation pattern, and it gives you a full 3D radiation pattern over here. You can see it on the left side. So now you see all your side lobes, and this is a full 3D measurement because we're rotating everything on 2 axes. At the same time, it can follow the beam coming on the transmitter from the left side, which is right over there. So by following the beam, you're basically always pointing the bore side at the direction of the transmitter. So you can see a plane, a surface plane, which is the received waveform strength as you rotate the beam. This is again critical because it shows you that the phased array can follow the peak power of the transmitter, keeping the system SNR high as it goes by. All the signals are generated directly from the Keysight instruments themselves. So this unit goes up to 44 gigahertz. Now these are 28 gigahertz phased arrays, and therefore creating modulation at 28 gigahertz with basically anybody's standard is trivial because you have so much bandwidth that you can do this. Now right now the 256 element phased array from MPI-Corporation is being used as a receiver, but you could also do it of course as a transmitter. And on the left side, using the horn antennas, using an identical box over here, is how the transmit beam is generated. But because everything is software connected and coherent and aware of each other, that's how you can create these 3D beam patterns, because you're doing a one system, one software platform, one hardware platform to create these very interesting beam patterns. These are critical for system testing and engineering testing. That's how these products eventually get released to the market. And of course, Keysight's entering quantum computing space. And one of the big challenges with quantum computing, as with any brand new field, is that this field is growing constantly and is scaling constantly. So you need a scalable solution, which is exactly what they're focusing on here. So the idea is that because your quantum computing bits right now, even being only at the orders of a few qubits, are going to eventually reach hundreds of qubits, you need a system that can keep up with that. But more importantly, you need a system that can have many channels all aligned with precise timing, because the lifetime of these qubits are so small. So you need to do everything you need to measure, compute with live feedback on whatever you're computing within the lifetime of a qubit, which could be hundreds of microseconds. So what they've done with their arbitrary waveform generators is that they have aligned them better than 1 nanosecond with exceptionally low jitter between the channels, and you can scale this up to 200 parallel channels at the same time as your needs for quantum computing grows. Now, as you know, if you're in this field, sometimes they are interested in doing modulation signals before they are sent to the qubits for some of the experiments, usually typically in the 6 gigahertz range. They have up converters dedicated for that with a very low phase noise DDS built into the PXI module. The signal is then directly sent to the up converter and digitized back onto the PXI module here. Now, we have FPGAs, silenced FPGAs with their own software platform here shown on the left, making easy configuration of new FPGA analysis blocks directly in there. And this gives you real-time processing, meaning that you can generate signals and look for the return signal from your quantum computer, make a decision, apply a brand new signal depending on what was read within the lifetime of the qubit, which is, of course, what you want. Otherwise, you lose the computation you were trying to perform. And all of this enabled by real-time processing, custom software, using PXI modules, ultra-low phase noise, alignments of 200 channels below a nanosecond, up converters, everything in one platform, which continues to grow as your quantum computing needs grow. And here we have the brand new Rohde Schwarz RTP oscilloscope, a fairly high-end model here. And obviously this is packed with a whole bunch of features. I'm not going to be able to go over everything, but this was released yesterday. And this is a 20 gigasample per second, 8 gigahertz instrument on 4 channels simultaneously. And there's a version of 16 gigahertz, which is going to eventually come up. Now, the main purpose of an instrument like this is obviously to do very complex analysis, and right now it's looking at a radar-type signal coming into it. One of the really neat features of this is that it has real-time de-embedding, and the real-time de-embedding is a critical aspect of being able to analyze your signal live. Now, unlike a traditional oscilloscope, where the embedding is done after the data is captured and displayed essentially through software, the built-in FPGA of this unit captures the data directly from the converters, does all the de-embedding on it, and then the triggering is applied. This means that if you have a bad channel, for example, if you have a cable that's lossy, or if you're measuring a backplane board that has a lot of ISI introduced into your eye diagram, you would be able to trigger on an eye diagram after the signal has been de-embedded by the FPGA and essentially ISI removed. And you can imagine for a triggering conditions like that, you really do want to do it after the signal has been de-embedded. So you can access, for example, the de-embedding menu here, and you can continue to add fixtures, cables. As long as you know their S parameters, you can go ahead and enter the S parameters here. For example, this is a fairly poor cable, has about 8 dB of loss at 8 gigahertz. Once all this data is inserted directly into it, you upload that, you let the FPGA then take care of the rest. And you can add more than one component here. You can add adapters, fixtures, or custom components in the middle. And of course, everything done in the background live, and then the triggering takes place, and that's going to be really amazing. I'm really eager to see if I would be able to get my hand on an instrument like this and play around with it. But it's, again, Rohde Schwarz innovation here at play. I am very eager to see the rest of the specifications. Very powerful instrument. Now, of course, with an instrument of this class, you're looking at something starting from $53,000 for a 4 gig model all the way to over $85,000 for an 8 gig model, clearly intended for very high performance applications. And just a couple other notes that I want to make sure that it comes across. I mentioned that this is going to have a 16 gigahertz model. And if you look over here, even though these look like BNC connectors, they're BNC compatible, but essentially they're type N connectors, and they have high performance and high, excellent frequency response at higher frequencies with the proper adapters that would be able to eventually run up to 16 gigahertz. Excellent for 5G, of course. Everybody is trying to do very high resolution demodulation. Now, this is an 8-bit architecture, but everything internally runs on 16 bits, and you can have a 16-bit resolution depending on what kind of bandwidth you're trying to work with, and these things seamlessly communicate with the spectrum analyzers, for example, that Rohde Schwarz has, connecting them to each other, creating a 5G testbed and characterization system where the spectrum analyzer takes control over the oscilloscope. It's one of the nice features that Rohde Schwarz have. Very nicely, tightly integrated equipment across all of their brands. And here we have the Rohde Schwarz FSWP phase noise analyzer, probably one of the best phase noise analyzers on the market. This is a 50 gigahertz model. Now, even though this unit's been around for a couple of years, there's obviously constant firmware and software upgrades to allow to do more and more functionality. So aside from doing the basic phase noise analyzer features like absolute and relative and residual phase noise, what they've added to this, which we're seeing here live, is the analysis of the pulse stability and phase noise of the pulse itself. So in a lot of radar applications, and even in 5G applications where you have pulse generation for phased array alignments and so on, you want to know how stable your pulses are from pulse to pulse, because that determines your system stability and ultimately the margins you have in your overall budget. So here, we have a pulse that's being generated in the background, many of them at a time, and you get these curves that tell you the stability of the phase and the amplitude of the pulse as a function of how many pulses are coming. So you actually can build a full statistical model of the pulse behavior across time, and you can even plot them in these really fascinating 3D plots. And here you can see the number of bursts on one axis, the position in the burst on another axis, and you can move it around, and you can see the trend across the different phase at the different positions of the pulse, and you can see it running live. And these things can have be quite insightful when you're looking for very rare problems, and can save you a ton of time when you're doing this analysis. And oh, I just changed something. Let's go back. So I'm sure I've talked about the software of Rohde Schwarz quite a few times. One of the best in the industry with multiple tabs. These are the people who basically pioneered this technique of having multiple tab measurements where you can switch back and forth across all of their instruments. The FSWP, one of the best phase noise analyzers on the market. So definitely check them out. I think it's a really interesting instrument. And here's two more brand new products from Rohde Schwarz, SMB 100B and the SMB V100B. These are essentially signal generators. This is a regular signal generator. This is a vector signal generator. And these guys really stepping up the performance and numbers that the specifications of these. For instance, they have over 30 dBm of output power, up to 6 gigahertz for the 6 gigahertz models, even though the one I'm showing down here is a 3 gigahertz model. So you get a watt of power from these units. Really excellent phase noise from the signal generator. But what's even more exciting on the vector signal generator side is that this unit can have 500 megahertz of instantaneous bandwidth available anywhere up to 6 gigahertz on the 6 gigahertz model. Now, if you're working on the 5G sub 6 gigahertz, of course, you have 400 megahertz of bandwidth available to you. This is ideal for research and for designing products and testing for the sub 6 gigahertz 5G market. And this one also has the 1 watt output power, built-in DACs on I and Q channels, so you can generate all the digital data internally and convert them to analog and create a modulated signal directly coming from the out of the unit. And I'm sure it also supports putting it from the outside of the unit using an external arbitrary waveform generator. But you can create your signals in MATLAB or any other software where you do complex modulation, download it onto this, and then directly have the modulated signal coming out of the output port. But at the same time, you can have standards that are built into here or directly right now. They're generating an LTE signal, which you can select from a list of available modulations already saved onto the unit. Really quite extraordinary. I'm very happy to see these. These guys start from about 10K to 15K. This says I think start from maybe 18 to 20K, and of course going higher depending on the configuration, the software options, and the highest frequency range. So take a look at the brand new vector signal generators and signal generators from Rohde Schwarz. And here we have another brand new product from Rohde Schwarz. This is a frequency selective power sensor, the NRQ6. And what makes this unit special is that if you're familiar with traditional power sensors, like the one over here. Power sensors are often extremely accurate, but at the same time, they have to capture the entire bandwidth of the sensor itself. So if you have a very narrow band signal, and you're interested only in measuring the bandwidth of the narrow band signal, you can't do it with a broadband power sensor. So what do you do if you want to preserve both frequency uncertainty or measurement uncertainty, as well as being able to do narrow measurement? So this is exactly what this product does. Here they're feeding two signals, two channels of very close signals to each other, to both of these sensors at the same time. So this sensor over here is seeing both of those at the same time, but the new sensor is able to have a channel as wide as 100 megahertz and as narrow as 1 megahertz. So you can select exactly which of the power of these two channels you want to measure without the other one interfering. So the interesting thing that they've done is that even though this is essentially frequency conversion based, it preserves the measurement uncertainty close to what you would get from a regular power meter. So for this one, it gives you 0.06 dB uncertainty. And if you look at the screen here, if you can see it, you can see the power sensor is reading minus 30 dBm because it's seeing both channels at the same time, whereas the frequency selective power sensor is reading minus 33 dBm, which is one of the two channels and therefore half the power. And these guys are power over Ethernet, so you can imagine mounting this in a remote area and being able to tune it directly from the Ethernet port and select the channel you're looking at. And of course, the benefits of having external synthesizers connected to it, your own sources connected to it. But the fact that they have managed to preserve the measurement uncertainty while giving you frequency selectivity is huge in a power sensor of this form factor, which I think can be very useful in this type of application. So here I am at X-Microwave, and if you have never heard of X-Microwave, these guys do some extraordinary things. So what they've done is they have made prototyping of microwave components essentially possible, quite inexpensive and very fast. So here they have a bunch of components from different vendors, Analog Devices, IDT, Microwave. It doesn't really matter. They have a collaboration with a really wide range of component providers. And what they do is that they take microwave components, which you typically would have to spend quite a long time into prototyping a PCB for, and they create a standardized footprint. And now this allows them to go on a grid, which means that if you want to connect these to each other, because they all have standardized inputs and outputs, not only can you populate from any vendor, we can also connect them to each other very easily. So you can imagine you want to build a synthesizer, you want to build a transmitter, receiver, radar, it doesn't matter. You will put them on a grid like Lego pieces and connect them to each other. Now, because of this standardized interface, it opens up a whole new set of possibilities. For example, you can have very low loss, high performance launch, like this one. This is a K connector, for instance, which connects directly to one of the edges or interfaces of these ICs, and it can go even up to 67 gigahertz, which is really quite amazing. And these components don't end at packaged parts. You can even have things that aren't packaged. Now, if I ever told you that you could prototype with dies on a grid breadboard type material, you would say, you're crazy, but they've done it. As long as you're obviously careful with these, you can see the launch of all these components, exactly the same standardized grid. So now you can take those and you can begin to create more and more complicated building blocks. For example, here's an example of that. So they come with these nice grids here. These things screw down onto this and connect to each other. And every time you have to go between two boards, there is a launch which connects them. It's a very low loss interface. I'm going to show you a live measurement of that interface between those boards. Now, RF is just one part of the big picture. You have DC, you have digital. A lot of these RF components have SPI interfaces, they have many bias components, and that is all handled through the back. So there are pins that poke through this device, like for example like this. This is a biasing block. You can see these pins go through these, and whenever you put an RF block on top, they touch the biasing pins from the back, and that's how you can bias the components and SPI program them, or digital interface I2C, it doesn't matter. And they have written software, custom software for Raspberry Pi, Arduino, for you to have a visual representation of these components across many vendors. And if you've ever done this on your own, you know how many tens of hours of time it takes to do this by yourself, and it's all been taken care of. A huge selection tool on their website where you can configure each of these components, program them to the vendor specification, and ultimately build things that are really quite extraordinarily complicated. Here's an X-band radar built completely from these components, biasing all at the back. Look at that. I mean, That's just amazing to be able to build something like this from individual building blocks because of the standardized components. And remember, this is one of those situations where you have to support many vendors, which they do, before this becomes useful, and the effort that's gone into it is really quite amazing. And once you're at the point where you're satisfied with your design, let's say you say, you know what, I like this design, I want to commercialize it, you can actually take this directly into a microwave chassis like this and end up with a product. So the transition from a prototype to a full product is quite simple. These boards actually come out, you can see. Once you're satisfied with them, you can create these footprints. They're all available. You know, this is this piece over here. Now this is in one piece, whereas this is all individual pieces assembled on here. Really, I would say one of the more exciting things that's happened in prototyping and design of microwave components and evaluating various things between different vendors, which is very difficult if you were to do this on your own by building a board or evaluating, trying to get the interface and the biasing all to work. And you can, of course, build these kind of modules. You can see biasing at the back. You can see RF components at the top. Really quite nice. I'm going to get a whole bunch of these here in my own lab at the signal path, and we're going to do a bunch of experiments with it, but I really wanted you to see what they've done and how far they've come and how much support is wrapped around this. So let's also take a look at the measurement of one of those transitions up to 50 gigahertz to show you what you can do, because you would think that these interfaces would not be very good, but they're actually quite amazing. So here's a live measurement of one of the interfaces as well as the boards. Now this network analyzer, this Field Fox from Keysight, has been calibrated to the measurement plane of the edge of these connectors, which means this measurement includes the connector, the transition to the board, about ½ an inch of trace, a transition to another board, and another connector. And at 50 gigahertz, this entire transition has about 3 dB of loss. So you're looking at very high performance components. You're not giving up much RF performance by cascading these devices after each other, which would be one of the things to worry about if you were prototyping using this technique. But they have spent a long time optimizing this interface, and then because they're standardized on their own ecosystem, going from component to component, you can rely on 3 dB loss from connector to board to board to connector. That's really good. So I'm very eager to get my hands on this. I'll have a link. Take a look at their product line, play with their websites, component selection. They have a really nice GUI. A lot of work's gone into this, and I think it's very exciting. So if you're familiar with any thermal management and especially stress testing your product, you'd know how critical a device like this would be. So this unit over here is really a high performance thermal management system used to, it can also connect to some of the other products they have. And you can see that the head over here right now is turned off so that you don't hear the sound of the air coming out of this. This unit can go from minus 80 degrees Celsius to 225 degrees Celsius. And unlike their competitors at minus 80 degrees Celsius, they can do 24 CFM. It's really quite remarkably quiet. And if I were to go ahead and turn on the air, you can see right now it's operating and it's going to reach very quickly to minus 90 degrees Celsius. You can see it's going down very quickly. Now, unlike some of the other approaches that the competitors to these units take, the exhaust of these units is placed in such a way that you don't have to worry about the frost or other materials falling on your samples. It makes it very quiet, it uses very little energy, and it has a linear compressor inside. So it's a rotary compressor as opposed to traditional compressors. And this makes it very quiet. And the heat generated from the unit is very, very low. So obviously you don't want your lab to heat up every time you run this. It's a very, very nice unit from MPI-Corporation, you can see right now. And to take matters further, they also have this box over here where this unit that I just showed you connects to, and the air intake taken on the right side allows you to create a totally custom chamber where you can put your devices inside and close it and do a very careful and controlled thermal experiments on them. They have these access points on each side, and they've gone as far as creating custom modules where even waveguide components up to W-band can go in and out of this box. So it doesn't matter what frequency of operation you have, this box will be able to accommodate and create a thermal environment for you to do all your testing on. A combination of these two devices, of course, is something that you would have to do on production running or on testing your devices or certifying them for operating at extreme temperatures, automotive, military. So it's really quite amazing what they can do these days using high-performance thermal management systems. So one of the nice things that MPI also offers is a wide range of probes. Now these probes have some unique features. Because of their design, they have a very visible tip under the microscope. And if you ever landed any probes, you know how critical it is to be able to see the tip of the probe very clearly under the microscope. Now these probes use a MEMS technology at the tip, gives you a very high performance, very well characterized behavior, as well as a very long life. Now they have differential probes up to 26.5 gigahertz, and they are going to have even more products in the differential format in the upcoming years. But in a single-ended format, they have probes all the way to even 110 gigahertz. Here is a 110 gigahertz probe. It's difficult to see in this lighting condition right now, but it's got a 1 millimeter tip, and you can see how visible the tip of the probe actually would be under the microscope. So I highly recommend that you check out this product line if you're looking for long life, well-characterized probes, which are actually quite inexpensive compared to the competitor, and it would be an excellent set of probes for doing day-to-day measurements on a probe station. And here's a close look at this beautiful 1 millimeter probe with a long extended tip, which you can imagine would be very easy to see on the probe station. I can't wait for these probes to also be available in differential mode, which is quite nice for very high performance optical components, which surely require differential input and outputs. So probably one of the more exciting product lines from MPI are their brand new design probe stations. Now, one of the things that makes these probe stations unique is that the engineers have spent time to design these from the ground up, highly focused on the application which you are going after. Now this allows them to create solutions which are really focused on what you want to do. And if you've ever used a probe station that hasn't been intended for the application you want, you would surely notice how difficult it is to use and how cumbersome it is, especially for millimeter wave applications where you have big millimeter wave modules and heads which need to move with the probes with extremely high accuracy. These are heavy modules. And they have some really neat innovations. For instance, in order to move the chuck, if the instrument knows that you are not landed, it will allow you almost free movement of the chuck. So for example, right now the probes are not landed, so I can just grab this and move the chuck around with quite ease, and large movements can be accomplished this way, where normally you would have to turn these rotation knobs forever to get to where you want. And once you're satisfied with that, you can go ahead and land the probes at different precisions and at different levels, and then the instrument would lock this and wouldn't allow you to move the station anymore, which would protect your probes, of course. Now there is very fine movements, which you can see with these knobs over here. Once the station is locked, then you can do very fine adjustments and movements after that. So let me also show you this nice design they have here for landing the probe. So right now the probes are not landed. As I showed you, you can have free movement here. Now as soon as I land the probes by just touching it, so now we have contact, the contact line is on, so you know that this is locked, you can no longer move it, but you can still move the probes up and down by very precise movements, 50, 100, or 150 micron distances, and this allows you to get extremely high repeatability landing on the probes while still allowing you very fine movements. This probe station is really quite amazing, considering how much weight there is and how much movement is required and how much precision is required. And if you're in the millimeter wave industry and looking for a very flexible probe station designed specifically for this application, highly recommend that you check out MPI-Corporation. So let me show you a couple of other really neat features. Now what they've done is that they have designed the millimeter wave head controllers in such a way that they do not interfere with the chuck. Now traditionally, this is a 1.1 terahertz head here. Normally these have to sit quite a bit higher, which means that you have to have an S-band that goes from the output of this multiplier directly to your probe. Now as you know, when you're in 1.1 terahertz frequency, dynamic range is really precious, and anything you add to the system is going to eat into your dynamic range. By eliminating the bands, by designing this to be so close to the device under test, you can even do load pull measurements without anything other than a direct connection to a pure probe. You can see right there a waveguide probe directly connected. Microscope has a very narrow design there, which has a long working distance, allowing you to come very close. And these things can be quite beneficial at terahertz and millimeter wave frequencies because you really don't have dynamic range to play around with. The flexibility of this probe station is really, really nice and gives you an idea of what you can do if you design a probe station from the ground up for millimeter wave applications and terahertz applications directly. And here I am at the Siglent booth, of course. A lot of you are familiar with the Siglent products. I've done quite a few reviews for them as well. In fact, recently I reviewed this somewhat new product, the Siglent STG 6000 series, a 500 megahertz, 2.4 gigasample per second, 2-channel arbitrary waveform generator. And this particular unit, as I've done the full teardown, you'll see it uses a DAC inside from TI, which is able to do modulation up to 500 megahertz with whatever 20 or 30 megahertz of modulation bandwidth that you can arbitrarily define anywhere there. It has tons of built-in functions, lots of features, quite exciting. Definitely take a look at it on my website. There's a lot of interesting applications that you can use this instrument for. This is probably a little bit more exciting since it's a brand new instrument from Siglent. This is their first vector network analyzer unit. This one goes up to 1.5 gigahertz, the SVA 1015X, released in about 2 weeks or so. And it has all the features and capabilities that you saw me review on the Rohde Schwarz kind of equivalent as a network analyzer unit. The Rohde Schwarz one was up to 6 gigahertz, of course, but the fact that a built-in vector network analyzer can now be embedded in such a low-cost unit is really quite exciting. And one of the really nice things about all the new instruments that Siglent is putting out is they're all running essentially the same micro Linux or Linux variant, and this allows them to have a coherent and consistent GUI as well as a web interface which supports mouse directly on the units itself, and a very fast GUI interface where you can look at the instruments directly on the web browser responsive. Unfortunately, I don't have that live demo here, but it's supposed to be quite good. So hopefully I'll get my hands on this sometime in the future. We can take a look at it. Really nice to see competition with somebody else like Rohde Schwarz, coming out with very similar instruments, meaning that definitely they understand the market and the need for these type of instruments out there. And of course, Siglent is getting into some of the higher performance oscilloscopes here. So this is a 500 megahertz 5 gigasample 4-channel model, and the 1 gigahertz version of this instrument is also going to become available sometime towards the end of summer. As you can see, large touchscreen, nice modern design. They're really pushing the boundary of what you can expect from Siglent instruments. I'm eager to get my hands on this as well. Now this, just like the VNA that I just talked about, runs the same micro Linux, has a mouse interface. It's quite nice and fast and responsive with lots of features, lots of software features which they continue to add on. So it will be cool to see it in action when I get one. And just to complete the picture, here's a Siglent SSG 3032X 9 kHz to 3.2 gigahertz vector signal generator. So as with instruments in this class, you'll be able to do various kind of modulations with this up to 3.2 gigahertz. And in fact, they do have this the nice diagram here that tells you how you want to condition your signal, and you can see IQ will be supported on this instrument. It's not installed on this one, but nice to see a signal generator coming from Siglent. Now I don't have a full detail and specification of the phase noise and everything, but you would expect something reasonable for the price point of this unit. But the combination of the signal generator, oscilloscope, vector network analyzer, and everything really makes a full ecosystem, which of course every vendor strives for, to make sure that you have every bits pieces required to do a full system test. So I'm excited to see what they're going to come up with next. And here I am at the Signal Hound booth. If you've watched any of my videos, you'll know that I've done quite a bit of review of their products. They're specialized in USB-based instruments, quite high performance. And I'm going to talk about 2 of their products which are brand new, I think worth focusing on. One of them is a reference and the brand new SM200A broad spectrum analyzer, extraordinarily fast. I'll go over some of those specs with you. So here is the PNCS1, a 1 gigahertz phase noise clock standard. Now this is intended for characterizing other instruments. It's an exceptionally clean 1 gigahertz source, and they've spent a long time optimizing this source to have very good phase noise, very low jitter, very little spurious emissions coming out of it. So the phase noise at a 10 hertz offset is below minus 90. At 100 hertz, you're already at minus 120, and by the time you reach something like 100 kilohertz, you're below minus 150 dBc per hertz. So it is so clean that if you were to hook this up to, say, another spectrum analyzer, you would essentially see the noise of the other spectrum analyzer. Now you could also build your own devices to divide the output of this further down or multiply it further up and preserve excellent phase noise. It's an exciting little component here that would be great if you're trying to have a unique and steady reference for all of your measurements, which I quite like. But really what is really exciting is this instrument up here, and I'm going to be doing a review of both of these later on, but let me tell you a little bit about this, because the engineering that's gone into designing this is quite amazing. So the SM200A, as I was mentioning, is a spectrum analyzer. This is a real-time spectrum analyzer. It goes from 100 kilohertz to 20 gigahertz. But what's extraordinary is that it has an analysis bandwidth of 160 megahertz, 110 dB of dynamic range, and a sweep speed of 1 terahertz per second at a 30 kilohertz resolution bandwidth. So you can imagine what kind of processing is required inside the unit to accomplish that. The custom FPGA load in there directly communicates with all the mixers and all the converters in order to be able to give you that terahertz per second sweep rate. And of course, with such a high sweep rate, you're essentially running up to what is legally possible unless you're doing military applications, and you can catch interference, you can find their software is quite comprehensive. Like I said, I will do a full review on this. I just want to make sure that you know such a product exists. There's a full API available. It's a USB-based instrument, connects to the computer. Here, in fact, they just have a little sweep going on here, which I think is worth looking at, just so you can really get an appreciation when I say how fast it really is going on. Right now, it's sweeping from 750 megahertz to 20 gigahertz in 15.14 millisecond at a 30 kilohertz resolution bandwidth. So it catches extremely rare events very, very quickly. Now, a lot of the processing is done on the unit itself, so the FPGA handles a lot of the required capturing and analysis and alignment. And what they've also done, which really is going out of their way, is to ensure that the phase noise characteristic they give you and the specifications they give you for this are valid down to minus 40 degrees Celsius. If you've ever done any PLL design and you know how a large temperature range affects the phase noise and the behavior of a synthesizer inside the spectrum analyzer, you'd appreciate what they've accomplished here. And the minus 40 degrees Celsius, of course, allows this to be mounted outside for live spectral measurement and monitoring interference detection and very rare event detection, and making this ideal for this type of industrial applications. So I'm looking forward to doing a review of this, but I wanted to make sure that you know this device exists, and definitely check out their website so that you can get more information all about it. So here I am at the mini circuits booth, and of course everybody knows about mini circuits. They sell tons of different components, but something that they've gotten into, which I think is worth talking about, is into the education system. So here they have a kit where you can build your own VNA. This particular one is a 6 gigahertz VNA. Now at the heart of it, there's an SoC by Vayar, which is an Israeli company, and I'm sure you've heard about this chip. This actually is at the heart of the Velobot radar system. So it's got D2D converters, D2A converters, up converters, down converters, switches, everything required to build the core elements required for a network analyzer. Now you couple that with some of the mini circuits couplers over here, and then you get a kit where you can have your own network analyzer. And the nice thing about this network analyzer is that it's essentially completely open source, just like the Velobot radar system is as well. And you can hook this up to MATLAB or Python, write your own code. And the cost of this kit, with everything included, is $2,500. Now for a 6 gigahertz network analyzer that's fully customizable as an education tool is I think is fantastic. So universities can certainly benefit a huge deal of getting something like this. Now when you buy it originally, it comes with its own code, so you get kind of a starting point, how to write the code, and I think it's in MATLAB, the code that they provide for you, and then you can build your own GUI. In fact, there is a GUI prepared right over here. You can get an idea of what that GUI would look like. Here on the left side, you can see full S parameters that have been generated from some basic simple code. Control is all over here. You can see the pictures of the ports coming in and out of this. Now, this is quite powerful, particularly because of the attention paid and because of the custom SoC. So it makes it really quite compact. Now, at the same time, you have to, of course, study what's in the chip to really genuinely appreciate the complexity of the system. But for students to put together the RF signal path of a network analyzer in such a straightforward way at the cost that this thing provides, it's really nice. So I hope you check that out. And the chip that's in here has many other applications. I'm excited to see it in a different product as well as the radar that Velobot provides. So check them out. So while we're here, let me show you another interesting set of products that Mini Circuits has. These are all LTCC embedded, various microwave components, high pass, low pass, band pass, balance. These are truly sub-wavelength parts. I mean, this is an O2 component, which is a high pass filter just for Wi-Fi applications. It's tiny. You cannot even see it compared here to the tip of my pen here. But what is really nice is that they're working on these components to go all the way to 40 gigahertz. So they actually have millimeter wave components here. Let me show you a couple of other examples. Yeah, here's another example. For example, this is a 11.5 gigahertz center frequency bandpass filter, 30 dB rejection at 26 gigahertz. Look at the size of these things; they're extraordinary. Being able to design these at sub-wavelength in the form factor, this uses a proprietary technology from Mini Circuits, and these are obviously intended for to be embedded in the next generation of 5G products or any kind of millimeter wave products that you would have, and they're trying to go even higher than 40 gigahertz. But definitely check it out, because the variety of components here they have in this LTCC technology is overwhelming, and actually there's no way that I can show you everything that is here, but they have little evaluation kits like the one over here, where you can have various components and try them out on your own custom PCB. Very cool technology coming from mini circuits. And continuing in line with millimeter wave components from mini circuits, now they have actually amplifiers. These are distributed amplifiers. This is a single die distributed amplifier from 50 megahertz to 40 gigahertz. There's about 11 or 12 dB of gain, 7 dBm compression point. So now they're really serious about creating these high performance millimeter wave components to go along with all of their LTCC as well as everything else they produce, and they're going to plan to create die versions of these to get even more gain and more output power by combining and so on. So nice to see mini circuits are really entering the millimeter wave market. So here I'm at Pico Technology. You've probably heard of this company. They have a wide range of USB-based instruments, spectrum analyzers, sources, vector network analyzers. Now this is an interesting PicoScope 500 series, an upgrade to an existing model which now adds digital as well, so now is a full MSO. One of the nice features of this unit is that unlike a normal oscilloscope where you will have a fixed resolution on all the 4 channels, they have this flexible resolution capability. So depending on the kind of bandwidth you're dealing with and depending on the kind of samples rates you're interested in, you can reconfigure the channels at a much higher resolution, all the way up to 16 bits. So if you are looking for a very high dynamic range, 80 dB of dynamic range analog performance, you can flash the firmware of this and create a single channel at 16 bits up to a certain frequency, and then you can get 80 dB dynamic range. Or if you're looking for 4 channels simultaneously, of course you can use it that way. This flexible resolution architecture is quite interesting, making it almost like a digital spectrum analyzer in a way, because of the high dynamic range. Now at the back of this unit, we also have now a brand new USB 3 interface up to 150 megasample per second can be directly transferred to your PC. Of course, you're going to have a pretty fast computer SSD to store that data, but the live streaming, as you can imagine, very powerful for catching rare events or a long-term storage of signals and doing post-processing on it can be very handy. Built-in arbitrary waveform generator, which is now common in a lot of instruments. All really quite small, nice and portable, powered from the USB, and an external source there, but I really like the flexible resolution. So take a look at the wide range of oscilloscopes they have. They have also some fairly high performance USB-based instruments, oscilloscopes as well. So take a look and see. They'll have something that fits in your application. And here we have the Pico Technologies Vector Network Analyzer. Now, this has got some interesting features which I think are worthwhile mentioning. So this is a quad receiver network analyzer, meaning that each of the channels have 2 receivers, which allows them to measure simultaneously the incident and the reflected wave. The advantage of that is that when you want to do full 2-port measurement, you don't have to worry about a switch going back and forth per port, and the switch uncertainties, of course, are very difficult to get out of your S-parameter measurements. And the reason traditionally you don't have quad receivers on instruments of this class is because, of course, of the cost. Now, they've included this as well as built-in BISDs per port. This is a fairly high dynamic range instrument, 118 dB. It has a quite nice software feature, which I will show you in just a second. Around $6,000 price, which is very reasonable for an instrument that has these capabilities. They also have their own custom calibration kits, which come with full data. These calibration kits are quite resilient, and if you break them, and especially in educational environments, which you can imagine, if I can get this thing in focus again, in educational environments, these things tend to break often because the students don't always know how to use them. These can be repaired per port basis, which is nice, reducing the cost of replacing them. Nice little small form factor, comes with a full set of data, and their software can do full analysis on the S parameters. It can also derive, based on FFT, the time response of your S parameters as well. So really a full-fledged network analyzer, directly connected to your USB port. A fairly good output power, up to 6 dBm per port of incident power, which is great for measuring passives with 118 dB of dynamic range. Really, there isn't much that you cannot do. So I hope you check them out. I think it's a fairly nice product. And here I am at the VDI booth, and of course everybody knows VDI for their millimeter wave and terahertz extenders. They support pretty much everybody's network analyzers. Very popular brand. Now what they have here, which is quite amazing, is a complete passive 250 gigahertz imager. So they're not gonna kind of show me what's inside the box, but they told me a little bit about it. It's a fully passive imager, so there's no illumination. 250 gigahertz radiation naturally coming off objects is being received through this window at the front, and inside there are 8 receivers, each of them with 40 gigahertz of bandwidth, centered at 250 gigahertz, with a series of optics and mirrors which move around to steer the beam. Now this gives them a 3 centimeter resolution at 3 meters, and they can detect temperature variations of sub 1 Kelvin. Now you can see a few images of people walking around, and that's kind of me standing in front of it. And if you have items below your clothing, it will obviously show up at 250 gigahertz because of the radiation. Now this is a security device, obviously, for looking at devices hidden in people, but what's amazing is the kind of noise they get and the kind of image quality they get, given that it is fully passive, so there's no illumination, which is a huge deal, testament to the design of their terahertz components, which is used in network analyzer blocks. And here's another application of the same circuitry. Same as blocks are used, except for a different optic here, being able to use for industrial application, looking for surface imperfections and hidden impairments in devices and components. Here there is a plate, and on this plate there is something drawn which is not visible by optical frequencies. It is only visible at 250 gigahertz in sub-terahertz frequencies there, and you can see the image generated. You can see the happy face, and that is going through the plate that is in front of it, and they're using a light source as a radiation source so you can get something through. So for as well as security application, industrial application from a VDI, this is the first time, at least that I have seen, such a large-scale implementation of what otherwise are their network analyzer components. Really nice to see that technology coming into other applications. So here I am at the SAF booth, and they have something that you have probably never seen before. This extraordinary device I'm holding in my hand is actually an E-band spectrum analyzer directly with a horn antenna. And this particular model is a 50 to 90 gigahertz horn antenna attachment there. Let me get this in focus. And this is a full spectrum analyzer used for surveying and catching spectrum leakage. It's fully independent, standalone unit, runs everything internally, battery operated, and that's all it is. It's literally a camera that you're holding in your hand where you can detect E-band spectrum. They have multiple versions of these devices spanning anywhere from low frequencies all the way to 86 or 87 gigahertz. So the advantage of these devices are, of course, aside from portability, they're quite inexpensive, all ranging less than $25,000 for some of the higher end models, and there's a full, I'm going to link to the full product lineup that they have here. And because of the fact that this is essentially like a camera, it enables some very interesting setups. For example, here we have one of them connected to a horn antenna here, where you have a camera, where you have a telescope at the top where you can look at the target you want to monitor with a high gain antenna directly coupled into their device right over here. So these things would be quite nice, and not just for interference hunting and looking at spectrum that you're looking for in a particular direction. You can also imagine using these in the lab as inexpensive portable spectrum analyzers. They come with a wide range of accessories, attenuators, and different PC software, of course, fully compatible. You can hook it up to your computer through a USB port and get this GUI capture results and take measurements. And of course, the dynamic range of a unit like this is not going to be the same as the dynamic range of a real bench spectrum analyzer, but for many, many applications where you don't need a huge dynamic range and you're looking for a signal in a portable fashion, all the way up to E-band, that's crazy. This is a really nice and interesting product. I highly recommend you check out what they have, and I'll link in their products, and you can look at the specifications and definitely see if it fits your needs. So here I am at the LPFK booth, and of course LPFK is probably one of the best known names in rapid prototyping machines. They have a wide range of them. Here's one on display. Now this particular Protomat S103 model has a full capability of automatic tool change, depth sensing, leveling, everything that you would want to do to get your PCB with extremely fine resolution. This has a 0.5 micron resolution, and with the head spinning at 100,000 RPM, which is of course very good for softer material. Now the way this machine is designed, the philosophy is you set something and you forget about it, and it will do everything it needs to do, change the tools, make sure everything's done correctly, and you close it, you come back, and your board is ready. Of course, local in-house prototyping is critical for security, rapid return of what you want to work on, but having something that you just set and forget is really important. Nowadays, PCB manufacturing is so inexpensive, you don't want to spend time debugging or figuring out how your prototyping machine is actually working. This is all done automatically, and you will get a nice board at the end of it. It's a very nice unit. So now probably one of the more exciting products from LPFK is their laser etching system here. So this is basically state of the art, and if you ever see it operating, it almost looks like magic. So the idea here is that they use a laser beam to etch away the copper from a variety of material. It doesn't have to be a traditional PCB material, it could be ceramic. Anything that you come across that has that can be delaminated copper, they can etch that away and burn that away essentially with a laser. Now they have a patented technology where they can focus the beam at different depths, and that allows them to cut the material in a way to give you very fine traces without damaging and destroying the dielectric. And you can imagine this is critical in high frequency applications. So here we have it set up. And by the way, this can also be applied to multi-layer boards, because you will do this on one layer and then you laminate and you do this again and again, and then you can create a very complex structure, and it's really, really fast. So you're going to, my friend here is going to start that. So now you can see, by adjusting the laser power, they can drill holes, they can cut the borders of the board itself, and they can then create traces. So right now we're doing some of the holes on the ground plane of this RF structure that they're going to etch away. The red laser that you see is a guide laser that allows them to find out what they're doing, what they're cutting. This is all active feedback system. And there it is. You can see it etching away the copper at first trace. And this laser can go multiple times over the material. And this is important also because depending on how many passes you have, you can now control the width of the traces and the spacing that you're going to have on the material. So you can go as little as 1 mil lines, and you can go up to less than 14 micron spacing between these lines, which is really quite amazing. And it is fast. This board is going to take about 1.5 minutes. There it is. It's another pass. Now this UV in this machine is ultraviolet, so the laser is in UV. You cannot see it, but you can see the traces as it goes and interacts with the metal. What you're seeing is the interaction of the laser with the copper. And there it is. And it is finished. That's really quite amazing. Now these machines are obviously not cheap, but if you're working in this space, LPFK is probably the best in the world at doing this. So here I'm at the Teledyne booth here, and I bet you didn't know that Teledyne makes RF cables. They actually do have a really wide range of cables. Here they have an assembly showing a high density connector that you can pass through a chassis, for example. They make cables all the way up to 110 gigahertz at fairly low cost, and fairly good performance. They're competitive with the best in the industry, like Gore and other vendors who manufacture these things. Now one thing they have, which unfortunately don't have an actual unit to show you, is this product here, where they have a flange, let's say a WR10 flange here, going directly to a 1mm cable. So you have waveguide to coax conversion directly built into the cable itself. And this gives you a huge flexibility if you want to connect something that is waveguide to a 1mm cable and have the flexibility, of course, moving the cable around. It's too bad they don't have one here for me to show you. But I will definitely link to it on their website so you can take a look at the broad range of cables that Teledyne makes. These are obviously going to be used not only in their products, but in a lot of test and measurement. I think it's a nice catalog. And here I am at Maury-Microwave, and they have a brand new load pool, active load pool system, which I think is quite interesting. Now, a few things that makes this unit unique is that it has a 500 megahertz analysis window, which means that you can do your load pool up to 500 megahertz of active bandwidth. Anywhere up to 40 gigahertz, these units can go up to 40 gigahertz. Now, as you can imagine, in a 5G system, doing broadband load pool is quite critical. And they have full control over the A and B waves, which means that you can do full control over your load. That's how they modify the impedance of the system. And you can even look at a second and third harmonic at the same time. If you have the correct number of couplers here, you can look at second and third harmonic of the signal while you're doing this live load pool system. Now, the 500 megahertz window which you can do your modulation can be internally generated, which is great because you can then download your own waveform into this, and that waveform could be anything, could be OFDM, could be single carrier, whatever that is you're going to be using for doing your load pool. So you're really emulating the real life situation. Given that 5G systems have so much more bandwidth, you need a wide bandwidth load pool measurement system, which is exactly what this box does. There is an amplifier here under the table which is required for some of the amplifications to close the loop, but with built-in 500 megahertz bandwidth, full control over AB waveform, pretty powerful unit working all the way up to 40 gigahertz. So here I am at the Noisecom and Boonton booth here, and they have a fairly interesting setup that shows off some of the capabilities of both their noise sources and their active power sensors. So here we have a noise source on the right, and this is actually an over-the-air measurement, and they're injecting a 40 megahertz wide noise into a 2.5 gigahertz antenna, and they're capturing that through another antenna. Now, this is a setup that you would be doing over-the-air calibration. Their noise sources are capable of doing that. But what's interesting is that because their power meters here placed on the right side, these power meters have the ability of capturing instantaneous power as well as average power. Now, if you've ever done any experiments where you have a large crest factor variation, and especially in OFDM modulation, you know the importance of being able to capture the peak power. If you miss that, then it fools you into thinking your amplifier's performance is different than what it is. So for instance here, they have an external amplifier where I can change the attenuation level. And by changing the attenuation level, I can change the crest factor of the amplifier. But the amplifier is recording several different numbers to me. It's giving me average power, but it's also giving me the peak power. Now, by noticing the difference between how the peak power changes, even though the average power of the amplifier isn't changing, but because the peak power is changing, it can tell me that the crest factor is degrading. Now, the active power sensors that Boonton sells can go from 50 megahertz all the way to 40 gigahertz, and there's a wide range of applications, of course, which you cover that. And as you know, in 5G ecosystem, peak power is very critical because a lot of times people are thinking of using OFDM. And this complete ecosystem of solutions between Boonton and Noisecom will allow you to do a whole wide of applications and experiments here. So here I am at Guzik, and what they have is something really interesting. So if you remember, I did a full teardown of the Keysight's S-series oscilloscope, and Keysight has a 10-bit architecture, 64 gigasample per second ADC, which is going into the really high-end scopes as well. And what they're doing is that they're taking the ADC from Keysight, and they're the only company who has access to this technology, and they're putting it into an AXI module here, and they have fine-tuned and optimized the performance of the A to D converter into 4 channels, so they can do up to 10 gigahertz of bandwidth, 10 bits at 32 gigasample per second on 2 of these channels simultaneously, or half of that bandwidth on 4 channels. Now, what makes this even more special is that they're not just throwing away the data coming from the A to D converters and then post-processing it later. They have an Altera FPGA built into this with optical interface. These are VCSEL transmit receive pairs there, which they transmit all the data out, so you can do real-time 10 gigahertz IF bandwidth on 2-channel processing by downloading your own code into the FPGAs. And this opens up, of course, a whole new possibilities, and it's a real-time processing for 5G applications, especially the fact that you have 10 gigahertz of bandwidth. Another thing they've done, which is very useful, is they've further optimized the A to D converters because they have access so close to the hardware itself, and they are able to do SFTRs up to 70 dBc, which is really, really great if you want to do this kind of application. Up to 10 gigahertz, that's a really broad bandwidth. You can imagine how much data is generated from these 4 channels internally, which are then all processed with the FPGAs. Now, they also sell these digital cards separately with these VCSEL interfaces, so you can occupy multiple of these AXI modules there, and then continue to do real-time processing, write your own code, do your own kind of modem algorithm, error correction, or whatever you want to do in 5G applications. Now, these cards start around $100,000 each, and you know the S-series scope with the full bandwidth is about $80,000. So it's a fairly competitive pricing, and it's built into the AXI module. You can have multiple of them, synchronize them. And here I'm on the top right. They're actually showing a live demo just to give you an idea of what we can do with this A to D converters and optimize performance here. They're occupying, at the bottom you can see that occupied bandwidth of almost 8.2 gigahertz. This is a 56 gigabit per second throughput that's being processed, 256 QAM centered at around 4.5 gigahertz. Exceptionally good performance, EVM 1.7%. SNR of over 30, and this is from IF to IF, so you can get an appreciation that what the noise floor and the floor of the performance of the instrument is. So then you can go ahead and do things like up conversion. Here they have a link set up between 2 VDI modules, so then you know what is the ultimate best EVM you can get from this unit itself. So definitely check it out. Highly optimized 10-bit A to D converter architecture with real-time processing on Altera FPGAs. Very interesting architecture here. See, here I'm at the Connectronics booth, and you can see they have a variety of connectors here on display. One of the unique features of this company is that they will make custom connectors of pretty much any number that you would need. They support all the way up to 26.5 gigahertz. There's really no minimum size order for them. They're working continuously to increase the frequency of operation, going all the way to ultimately 67 gigahertz, 1.85 millimeter connectors. But if you're in the market for highly customized connectors that you would ultimately put on a PCB or connect to some kind of a cable, and you're looking to prototype something very quickly at small order numbers, definitely check out Connectronics' catalog. And here I'm stopping by AJ Tuck Company, and these guys do something really interesting, which is electroforming. Now, by electroforming, they can actually grow metal of any size, dimension, and frequency range you would want. And these things can be as thin as 1/1000th of an inch. And you can imagine for creating really large structures, for example, like this, even by doing this electroforming technique, allows it to be super thin, making them very light. Aside from that, somewhat impossible shapes can arise from this, because you can do this electroforming around other material and then dissolve the other material, end up only with the metal. So there's really it's quite amazing to see the different shapes and pieces that they can manufacture. Now, these are highly custom made waveguide components, different kinds of microwave components, or any kind of shape, lenses, reflectors that you want to manufacture. I think their catalog is really quite wide, really interesting shapes that can be manufactured using this technique. And if you're looking for a totally custom-made component that's unusual and fitting for a specific application, I definitely think you should check these guys out. So here at HyperLabs, we have a wide range of very high-performance microwave components, including down converters and broadband balance. And one of the interesting things about their design of their balance is that they have modules that go all the way up to 81 gigahertz. In particular, for example, this particular model here, you can see, we're dealing with 1 millimeter connectors on each side. And these things, despite being ultra broadband, still have very good performance and very good amplitude and phase balance. In particular, here we're looking at a 70 gigahertz version that has a rejection of about 1.5 dB of variation across its band. The phase is good, better than 10 degrees up to about 65 gigahertz, which is quite nice. These things come in some very interesting form factors. This particular form factor with a micro coax can be soldered directly on a PCB. And if you want something that is pick and place compatible, they have this other type where they're using these snap-on connectors. These are obviously microwave connectors, and it's held in pretty tightly on this module. And you can put this in a pick and place machine, and these connectors here are compatible with PCB mounts, in which case afterwards you can easily mount this. And this gap that you see here is designed specifically so that other ASICs can sit underneath this module, so you can bring the single-ended to differential conversion of the balun right up to the edge of the IC, which can be, as you can imagine, very beneficial. This is just a little cell they've built just to test this and demonstrate this. Really, it's not necessary. This is the product that we'll be selling. And a lot of these components are highly engineered using thin film devices, and they have an example of a very linear mixer, up to 60 dB harmonic rejection mixer here. This particular model is, I believe, 20 gigahertz, and you can see a very clever design, of course, that goes into these. They have their own technologies of single-ended to differential conversion built into these modules, so they can get differential lines going into their own thin film component that they have designed. It's all designed in ADS and simulated and, of course, verified. So if you're looking for very high performance and even going as far as specifically selected, hand-selected and factory-calibrated match pairs of balance and power dividers, you definitely have to check out HyperLabs. They also have other products. I'll link the website below. And here I am at Holzworth Instruments. If you know about their unique instrumentation, you know that they make some of the lowest noise phase noise analyzers on the market. Now, these are cross-correlation phase noise analyzers based on digital down conversion and digitizing the waveform, and they can do additive noise, they can do residual phase noise, they can also do analysis on AM noise. Now, they have updated the RevD version of this instrument. Now it goes all the way up to 40 gigahertz, so you can do all the cross-correlation measurements that you could do to sub 6 gigahertz. Now you can do all the way up to 40 gigahertz. Nice access to the baseband input directly, so you can put even baseband inputs going into the FFT engine for the cross-correlation algorithms directly from the front panel of the unit. Their noise floor is astonishing. For 100 megahertz at a 20 megahertz offset, you can get down to minus 200 dBc, which is insane. And of course, the more cross correlations you build, the lower that noise will be. They also make RF synthesizers as well, but if you're into doing extremely precise and repeated and reliable and configurable phase noise analysis up to 40 gigahertz, it's great to see that the D-Revision can give you those features. There, I hope you enjoyed this video. It was really fun recording it, and if you want to support the channel, you can always support it on Patreon. You can subscribe to the channel, and to increase the engagement of the videos, you can let me know in the comment section what you thought. I think I'm going to try and do this again next year with even more content, and hopefully it will be even more exciting. There's obviously a link at the bottom. You can look at all the websites. I'm sure you already figured that out, so you can jump to each of the different vendors. And I think it was wonderful. So I'll see you in the comment section, and we'll go from there.